Welcome to video number 2 in our module about public health. This video is titled Measuring Disease in Populations. In this video, we're going to talk about different types of statistics that can help us to measure and track disease among the people we are serving, and this can help us make better decisions to help guide our public health efforts according to the data. In this video, I am going to introduce you to several different statistics that help us to track disease in our population. These statistics are important tools, and these tools give us data that helps guide our decisions so we can make the best decision for the people we are serving. I will briefly go through each of these different statistics now, and then throughout this video, I will go into more detail and teach you how to use them. The first statistic is called incidence. Incidence tells us how many new cases of a disease are happening in a given time frame. For example, how many new people have gotten tuberculosis during the last year? That would be incidence. And so incidence helps to tell us how fast a disease is spreading. The next tool we'll talk about has two parts. The first is mortality, and the next is case fatality rate. Mortality is how many people are dying from the disease. And then case fatality specifically says when someone gets the disease, what is the chance that they will die? And both of these together help us understand how deadly a disease is. The third statistic or tool that we will discuss is prevalence. Prevalence basically tells us how many people have the disease right now, or how many people have the disease at a specific time. For example, we could see that the prevalence of high blood pressure among Cambodian adults is about 20%. So about 1 in 5 of the adults has hypertension. So that's telling us how common it is. How many people are there that have the disease? And this helps answer the question, how big is the problem right now? Moving on to our last group of tools, we will talk about risk and relative risk. Risk tells us what % chance does someone have of having a disease or having a bad outcome. What is the chances of it happening? Relative risk is different, but it's related. Relative risk tells us how much does a treatment help you. So relative risk can help us know, is a certain treatment reducing your risk of a bad outcome, or does it increase the risk of the bad outcome? And so together, risk and relative risk help us understand how much does a treatment change your outcome. On this slide, we are talking about our first statistic, incidence. Incidence helps us know how fast a disease is spreading. And the way you calculate incidence is actually quite simple. You just need two important numbers. The first is you need the number of new cases. And the second is you need the population that was at risk in a specific period of time. So let's do an example. In Cambodia, a recent study found that there are about 272 new cases of TB for every 100,000 people per year. So we can calculate the incidence. The number of new cases we have here is 272. And then we divide right? We divide by the population that's at risk. So 272 new cases for every 100,000 people at risk in a year. And what does that give us? Well, you can pull out your calculator, and I believe that gives us an incidence, a rate of new disease that is 0.00272. Or we can make it into a percent. That means it's 0.272%. That means for every 100 people at risk of tuberculosis, there would be 0.272 new cases. And so, just looking at our slide here, incidence, it measures the speed at which a disease is spreading in the population. So if the incidence goes higher, that means there are more new cases happening. And if there are more new cases happening, the disease is spreading faster. If, however, the incidence of the disease is going down, that means less and less people are getting the disease. And so that's a good sign. If we start a program to treat tuberculosis across Cambodia and try to find new people who are sick and treat them as quick as possible, maybe we will see the incidence of tuberculosis going down in Cambodia, because when we treat people, then it won't spread to new people as much. So the number of new cases will decrease. So that's an example of how the incidence can be used to help us make good decisions for public health. We'll do one more example because incidence is such an important statistic. So in this example, I want you to tell me if a specific village is having higher rates of tuberculosis, of new cases of tuberculosis, compared to the rest of Cambodia. Does this village have a bad tuberculosis problem, or are they okay? And so in this village, we had 42 new cases of tuberculosis. And the population of this village, let's say, was 8,000 people. I'll write that a little better. 8,000 people. So, what was the incidence of tuberculosis, of new active cases of tuberculosis in this village? And how does it compare to the rest of the country? Well, we just do some simple math. We take 42 divided by 8,000, and that is 0.00525, which, if we make it a percent, that is 0.525%. So you can see here, let's do a different color. You can see that this incidence here is more than the incidence for the rest of the country. For this village, the incidence is 0.5%. But for the rest of Cambodia, it was 0.2%. And so that can help us know that in this village, tuberculosis is spreading quickly. And maybe we need to send more resources or more medical professionals there to help control the disease so it doesn't keep spreading. Does that make sense? Do you feel like you are understanding incidence better? If you have any questions, please remember you can always enter your questions in the comments section at the bottom of the web page. Okay, we'll go on to our next statistic, our next tool. On this slide, we are talking about prevalence. Prevalence is a statistic that tells us how many people have the disease, what fraction or what percent of people have the disease at a specific time. And so to calculate this statistic, you can see here, we need the total number of existing cases, and then we divide that by the total population. And so what this statistic does is it measures the total burden of the disease in the population. How many people are suffering from this disease? For example, in Cambodia, 1 in 5 adults, or about 20% of adults, have hypertension. How do we calculate that? Well, let's say that in one group of people, we had 25 adults who had hypertension out of 125 people. We have 125 adults show up to our screening, and then 25 of them had hypertension. So you do the math, and you take 25 and divide it by 125. And that equals 0.2, which is 20%. Does that make sense? To go from 0.2 into a percent, you have to multiply by 100. Multiply by 100. And that makes it into a percent. And so prevalence helps us know what the clinicians, what the doctors and the nurses and the pharmacists will see in practice. Conditions that have a very high prevalence are very common. Conditions with a very low prevalence are very rare. And so if there's a high prevalence, that means that it is probably a very important public health priority. And for many conditions that are chronic diseases, the conditions last a very long time. And so this prevalence can help the health ministry to know how many patients need long-term care. If you know the prevalence of diabetes in the population, then you know how many people will need care for their diabetes. So that's an example of how we can use prevalence in making public health decisions. Okay, before we move on, I wanted to review incidence and prevalence and talk about some of the important differences, because I think it's easy to get them confused sometimes. Incidence, remember, tells us how fast a disease is spreading. It tells us how many new cases occur in a specific time, the new cases. Prevalence is different. Prevalence tells us how big is the problem right now. How many cases are there in total right now? So it measures all of the existing cases at a specific point in time, not just the new cases. It tells us all of the cases. So here's some Cambodia specific examples. In Cambodia, one study found that the incidence of tuberculosis, active tuberculosis, was 272 cases for every 100,000 people per year. That means 272 new cases of tuberculosis for every 100,000 people per year. However, a different study in 2023 found that there were 546 active cases for every 100,000 people in 2023. So can you see the difference? The incidence tells us the new cases. How many new people did the disease spread to? But prevalence tells us how many people already have the disease. Now let's look at hypertension. Imagine we estimate that there are 900 new cases of high blood pressure for every 100,000 people per year. 900 new cases of high blood pressure. But as you know, most people who develop high blood pressure, it can last for many years. For some of them, they may continue to have high blood pressure for the rest of their life. So it continues for a long time. And all those new cases add up each year so that lots of people have high blood pressure. And that is why we have such a high prevalence of high blood pressure. So the estimated prevalence of high blood pressure in Cambodia is 20,000 people for every 100,000 adults. So about 20%. And I wanted to point out something that is useful here. You can see that the prevalence of hypertension, the number is a lot bigger than the incidence. That gives us a clue that this disease must last for a long time, because if it lasts for a long time, that gives more time for the number of cases to keep adding up to a bigger and bigger number. So even though there is only about 900 new cases per year among 100,000 people, that 900, since it lasts a long time, they keep adding up. And so now we have about 20,000 people with high blood pressure for every 100,000. However, for tuberculosis, we see that the incidence of new active cases is 272 compared to 546 active cases being the prevalence. So that can mean two things. One is that because the prevalence is smaller compared to the new incidence, it means that the cases are not lasting very long. And this could be because we are treating them. So when they get a new active case, we treat it so it doesn't last a very long time. Or it could also mean that people are getting better by themselves, or that they are dying, because then when they die, they are no longer an active case. And so that would reduce the number of active cases. So if the incidence is close to the prevalence, then the disease lasts for a short time. The cases last a short time. But if the prevalence is a lot bigger than the incidence, then that means that the cases are lasting for a long time. And so incidence, as we discussed, is useful to track the spread of the disease, and it can help us know are our programs working, right? If the incidence of tuberculosis is small and it's decreasing, that means our tuberculosis treatment programs are probably working well. Prevalence, on the other hand, is good for planning the services we want to offer and understanding the burden of disease in the population. If we know that, for example, that high blood pressure is affecting 20% of the adults, that's a lot of people. And so we know it's a very big problem for the country. And so we can plan to prioritize treatment for high blood pressure, and we can give more money and services and do more training focusing on this area because it is one of the bigger problems. On this slide, we are talking about mortality rate and case fatality rate. These two statistics are very similar, but also different in an important way. And they help us understand how deadly a disease is. First, let's start with mortality rate. Mortality rate tells us in the total population how many people are dying from this disease. So, for example, we have here for the disease rabies, we see that 5.8 people are dying per 100,000 people each year. So that means of 100,000 healthy people at the beginning of the year, about 5.8 would die from rabies by the end of the year. Does that make sense? So you can see a very small number of people get rabies. But let's consider now the case fatality rate. Case fatality rate is different. Instead of starting with healthy people and seeing how many people get the disease and then die, we start with people who are already sick, people who already have the disease, and then we ask how many sick people with the disease will die. And for rabies, almost every single person who gets the disease and has symptoms will die. Nobody can survive it. And so that means the case fatality rate is almost 100%. That means if we had 10 people with rabies and we ask how many people will survive, it is 0. Nobody will survive if they already have rabies. But instead, if we have lots of healthy people, if we have 100,000 healthy people who don't have rabies and we watch them for a year and we say how many people will die at the end of the year, it will be on average 5.8 people, because most people never get rabies. But if they do get rabies, then they will die. On these next two slides, we are going to talk about risk and relative risk. Risk tells you what are the chances of having a bad outcome. In this slide, we're using the example of stroke and high blood pressure. When you have high blood pressure, this increases your risk for having a stroke. However, many people with high blood pressure start taking a medication to lower their blood pressure so that they have a lower risk of having a stroke. And so these statistics of risk and relative risk can help us to understand what is happening with stroke, the relationship between high blood pressure and stroke, and how much taking a medication will help. So, for example, let's start right here. For someone with untreated high blood pressure, 8 out of 100 people will have a stroke in 10 years. 8 out of 100 people. So we can calculate the risk of a stroke in 10 years. 8 people have a stroke for every 100 people. So we put the number of people who had the bad outcome on top and the total number of people on the bottom. And then we divide. And 8 divided by 100 is 0.08. Or we can make it into a percent. We take this number and multiply by 100, and that is 8%. 8% of people who don't treat their high blood pressure have a stroke. Now let's compare this to people who take a medication to help lower their blood pressure. In this group, we see that 4 out of 100 people have a stroke. So let's calculate their risk. 4 divided by 100 equals 0.04. Or we can times that by 100% and make it into a percent. So that is 4% of people have a stroke when they're taking a medication to lower their blood pressure. So I think you can see here that the risk of stroke when you take a medication is a lot lower. It's only 4% compared to the risk when you don't take a medication, which is 8%. On the next slide, I'll show you how to calculate relative risk to compare the two together. Okay, so for untreated hypertension, 8 out of 100 people had a stroke, which was 8%. Or we can also write it as the risk was 0.08. 8 divided by 100. For people who did take a medication, 4 out of 100 had the stroke. 4 divided by 100 is 0.04. Now we want to calculate the relative risk. So first, on top, we put the treatment group. On the top, we put the risk when you were in the treatment group. The risk when you take the medication is 0.04, remember? What about when you don't take the medication for high blood pressure? If you don't treat your high blood pressure, the risk of stroke was 0.08, so we put that at the bottom. And then we do the math. 0.04 divided by 0.08 is 0.5, which is 1/2. Now, what does this tell us? This number is the relative risk. It tells us your risk of having it tells us how the risk of having a stroke when you're on medication compares to your risk when you don't take medication. So we see that your risk when you take the medication is only half as much, which is very good. If this relative risk is less than 1, then it shows that the treatment is working. It is making your risk smaller. If the relative risk was more than 1, then it means the treatment is not working, that your risk is even higher. It would show that it's actually hurting you. 0.5, this is equal to 50%. So it means if you compare people who take their medication to people who don't, then the risk of stroke is only 50% compared to the other group for the people who take medication. So it shows they have less risk than the other people who theirs is 100% by comparison. All right, we are now at the last slide of the video. I want to do a final summary and review the 4 statistics, the 4 tools that we discussed in this video. Incidence tells us how many new people have got the disease. It tells us how many new cases of the disease there are in a specific time window. This helps us understand how fast a disease is spreading. Prevalence tells us how many people are already sick, how many people already have the disease. This helps us understand how big the problem is. Mortality tells us how deadly the disease is, how many people die from the disease. And relative risk tells us how much an intervention helped, right? When we talked about stroke risk, we found that people who took the medication, their risk was cut in half. They had half as many strokes. So this tells us that the medication helps reduce the risk of stroke. All right, after this video, on the webpage, you will see some practice questions. I think that some of the topics and ideas we discussed today can be a little tricky, but I hope that the practice questions will give you a chance to practice doing the math and help you to remember the concepts better. Thank you.